Hello, hiya Aaliyah, hiya Lynn, hiya Claire, and welcome to this latest lecture in the A Star series. So today, what we are going to do, we are going to focus on geometry, and in particular, we're going to focus on angles. So we're going to go through a lot of different rules to do with angles, and then we'll try and go through the rules at first reasonable speed, so that we've got some time to look at some past exam questions to do with it as well, and seeing sort of the questions you get where the rules to do with angles combine. Just before I start, I'm just going to share the playlist for this course. Welcome Anna as well. So I'm just going to share in the chat two links. The first one is for this series of lectures. So this lecture, as always, is being recorded. It will get uploaded to YouTube later, and you can watch it there as along with the previous lectures in this series. The second playlist is the previous running of a series, has a full playlist of that. Now, what I would say is sometimes it's beneficial to watch, although the topics are the same lecture in two different series, because often I will cover slightly different bits, slightly different questions, because many of the topics is challenging to cover the whole thing in an hour. So I might cover slightly different from one series to the next. And as always, I'm going to share on the screen as I go along. But if any of you've got any questions, please don't hesitate to ask. You can either write them in the chat, which I'll make sure to check intermittently, or it's no problem to just pop in your mic quickly as well. All right. So we're going to start by looking at some just like key rules. So these are just some basic rules that you will see come up time and again. Welcome Kutatana as well. And so the first rule we are going to show is with a triangle. So this rule is a very common rule. You see it all the time, and you would definitely see it as the part of bigger questions as well. And it is that angles in a triangle equal 180 degrees. So it doesn't matter what type of triangle it is. If the shape has three sides, it's a triangle, and the angles are going to add up to 180 degrees. In other words, A plus B plus C will equal 180. Okay, and then in terms of different types of triangles, you might see a question with an isosceles triangle. So we'll put that below this. Sorry, does this come through ginormous at the moment? We'll try and make it a little bit smaller. So we've got here, we've got an isosceles triangle. And so in isosceles triangles, the two sides and base angles are the same. So therefore, in terms of the shape, it's basically 2x plus y equals 180 degrees. So the two base angles are going to be the same. And that means if you've got an isosceles triangle, and an isosceles triangle, it often gets shown by these lines. So normally in the question it will tell you as well a triangle is isosceles to be honest, but it gets shown by these lines here. If you have an isosceles triangle and you're given one angle, you can find the other. So for example, let's give a couple of questions here. All right. So we've got here e.g. This question is simply find the missing angle in the isosceles triangle. I'll find a missing angle in the isosceles triangle. Okay, so because we know it's an isosceles triangle, we've been told in the question, and we've got two lines here as well. We know that the two base angles, which is always the two angles below the lines, whether the lines are, even if the triangle was the other way up, the angles below the lines are the base angles, so the ones will be the same. So in effect, we know this angle here is also x. So we can say 2x plus 50 equals 180. And now we can use our skills we know from solving equations in algebra. So we want to get rid of our plus 50. So to do that, we do its opposite, which is minus 50. Remember, whatever you do to one side of the equation, you do exactly the same to the other. So you'd have 2x equals 130. Sorry, does someone have a question? Go for it, Anna.
Yes, Joe, I have a question. Below, so the two, you're saying that the two equal angles on an isosceles triangle will always be below. Is no one ever going to be a bit mean and put the triangle in another side or another way, or is
Oh yeah,
that a
sorry, it's
mathematical
me. It's probably me choosing no a bad choice of words saying below actually, because I mean so for example, if you've got a triangle like this and you've got the two lines here, I'm saying below, but I realise below doesn't make logical sense because it's technically above. So thanks for flagging that up. But it's the ones after the lines would be the same angle. So whichever ones are the two after the lines. Thanks for flagging that. I'm sorry, I didn't make that clear.
Sorry, Joe. I didn't mean to be pedantic, but I just thought,
No,
oh wow.
no worries. Much better to check and be a pedant than other people may have the same question. So much better to check. Sorry about that. I should have been clearer. Um, all right. And so you've got here, we've taken away the 50, so we've got 2x equals 130. And so next, we want to get 1x. Remember, 2x means 2 times x, so the opposite of times 2 is divide by 2. So 130 divided by 2 is going to give us x equals 65 degrees. And that's our final answer. All right. Now just we've got one more example here because you could get an isosceles triangle, but the way you're given one of the base angles, but basically you can solve it in a similar way, though the other way around. So you see we've got an example here. I'm going to pull this to the bottom. So we've got here DEF is an isosceles triangle, and you need to find the value of y. Give a reason for your answer. Okay, so in this case, we've still got our lines. It's still not been cruel, so they still are actually below the lines to base angles, which means we know f equals 61 degrees because the base angles are the same. So now we can say y equals to 180, the total always, for a isosceles triangle minus 2 lots of 61, which gives us 122, which if we take that away, we can get to y equals 58 degrees. And that's our final answer there. Y equals 58 degrees. All right, and so often, as with a lot of the examples, which is why I'll try and get to the exam questions by the end of the day, you'll find triangles in questions, but they'll often be combined with other areas, and that's the case with geometry. Learning these key rules is vital, but it's then being able to recognize them in terms of bigger questions. But I'm going to move on now and do just another couple of key basic rules. Okay, and as always, if someone needs me to go back to a previous slide, just let me know. You can just put it in the chat if that's the case and what page it is, and when I see it, I will go back to it. All right. So the next rule we're going to touch on is another one to do with 180 degrees, and that is angles on a straight line. So um, so angles. And I'm just going to write in brackets because this sometimes confuses people. In one place, it's not all the angles on a straight line together. It's one place on a straight line equal 180. I'll put the degree sign in a sec. This is because for angles, make a semicircle. And so a circle has 360 degrees and half of 360 is 180. So sorry, I'll draw in all these little degree signs here. I don't know how to do it with a keyboard, to be honest. So that's why. So say if you've got a line here, I apologize, there's no straight line option on here, but you could have a couple of places coming out the lines here. So we've got our first one here. We've got A and B, and so A plus B equals 180 degrees. And you can see they make the semicircle together. Or down here, we can have C, D, and E. We can say C plus D plus E equals 180 degrees. You can see the angles C, D, and E do not affect A and B because they're in two different places on the straight line. It's always going to be the angles on one place on the straight line, even though we generally shorthand it, we generally call it angles on a straight line. And then just as angles in a straight line equal 180, well, angles on a point is double this. So we've got angles on a point equal 360 degrees. So you've got here, you've got A plus B plus C plus D equals 360 degrees. And as you can see from the illustration, this is because they make the circle, and a circle always has 360 degrees. You also just hear these phrases in general English language, to be honest. If you're meant to turn back on yourself, someone will say turn 180, or if you turn all the way around, someone might say turn 360, and that's why, because if you turn back on yourself, you're doing a semicircle, you're going back. If you're turning a 360, you're going around and ending up back around the same way. All right, this is an additional extra rule at this stage. I'm going to chuck in is angles in a quadrilateral. Okay, so we've got a quadrilateral up here. And so this is similar to a circle. So angles in a quadrilateral equal as well, just like a point, 360 degrees. In this case, A plus B. I'm just going to write this myself, it's easier. But yeah, so we've got A plus B plus C plus D equals 360. Don't know why I've gone capitalized here when lowercase, but hopefully you can work that out absolutely fine. So just before we move on, we're just going to have a look at a couple of questions to do with this. Okay, so this is an early question from a past exam. They combine some of the rules we have done so far. So we've got PQRS is a quadrilateral, PST is a straight line, and you need to find the value of y. So this will be a 2-mark question because it's got 2 steps to it. So the first thing I would do if I did a question like this is always working out what I can work out at a time. Well, we can't work out y straight away, but we can work out PSR, or I'm just going to mark it here as x, because x, or PSR if you want to call it, is in the quadrilateral with our other 3 angles. We can say x equals 360 minus, and then we got 130 plus 65 plus 95. Well, that's going to give us 230, 290, so minus 290, and so equals 70 degrees. I'm just going to put down here angles in a quadrilateral, and normally in the exam, all angles in a quadrilateral equals 360. Normally in the exam you have to write reasoning, so if you work out an angle you need to write out the reason why you got that angle. Okay, welcome tests as well. And so now we've got that first angle here. Well, now we can use that. Now we can use this 70 here to find y, because y equals 180 minus 70, and so it equals 110 degrees, which is our final answer. And the reason for that is angles on a straight line. Angles on a straight line equal 180, and notice the 95 in the corner has no effect if it's not related to these 2 angles. If a straight line continued up here, then this plus 95 would equal 180, but otherwise it's not related to this part of the question. Okay, so I'll just give a second again to copy that, and then we'll move on. Okay, so obviously we've touched on triangles, and we've touched on quadrilaterals and what they equal, but that actually is a rule for the or even an equation formula to find out the total interior angles of any polygon. And a polygon just means a 2D shape. Okay, so the equation is, and you'll find this works for a triangle and a quadrilateral, works for anything else as well, is the amount of sides minus 2 times 180 equals total interior angles. And then just to add to this, if the shape is regular, and a regular shape, you'll see 2 terms come up, and we'll see a bit when we come into shapes in the next class, but you can see regular and irregular. So a regular shape just means all the angles are the same, and irregular means they're not the same. The shape is regular, you can divide total interior angles by the amount of sides to find each interior angle. And once you get to five-sided shape or more, so pentagon, which is five-sided, hexagon, six-sided, shapes are just called regular or irregular. Smaller shapes with quadrilaterals, we may see in like the shapes class, there's a number of different types. You can know with triangles, you've got different types, but they all have triangle on the end of them. But we're going to make a table here for shape. Um, then we've got formula. We've got total angles. And in fact, I'm going to change that a bit so save a bit of space. We've got total angles and we've got individual angles irregular. And so here we can start with the shapes we've done already. So we've got a triangle. Any three-sided shape is a triangle, and so it's three sides. So we can do the three, the amount of sides, minus two, which gives us one, times 180, which is going to give us 180 degrees. And then individual, you could do 180 divided by 3, so it's going to be 60 degrees. Now next we've got quadrilateral, which is any four-sided shape. And again, this should back up what we said earlier. We've got four sides minus 2 times the 180, and that's going to give us, as we said earlier, the 360 degrees. And if you multiply that by 4, you're going to get 90 degrees, which hopefully most of you will realize 90 degrees is a right angle because a regular quadrilateral is called a square. A rectangle obviously also has the four right angles. So next you've got a five-sided shape, which is called a pentagon. Think of a building in the US which has five sides to it. The modern pentathlon in the Olympics has five events. Basically, the prefix pen, it just means five. Sorry, my voice isn't exactly perfect today. But yeah, if you do for this, you've got the five sides. Again, we follow the equation, amount of sides minus 2 times 180, and that's going to give us 540 degrees. And again, you could divide that by 5 to get each individual side, which is going to give you 108 degrees. And this will work for any shape. For example, a decagon, which is a 10-sided shape, could be a bit confusing. The prefix dec does mean 10. It's just the Romans messed up the calendar, which is why it's the 12th month. But decagon, it's 10-sided shape, so you've got 10 minus 2, which gives us 8, times that by 180. I'm actually going to cheat and put this in the calculator because my 180 times table is failing me, but that will give you 1440 degrees, which means each individual angle you divide by 10 would be 144 degrees. So you could, it doesn't matter what the shape is, you can use this equation and find out the amount of sides. All right, so I just saw that now earlier when I'm going to complete this slide and then I will go back to the previous one. No problem. Sorry, you've got a question as well. Is that the same question on going back, or is it something else? Um,
Yeah, please.
Yeah, it's just that to go back. No problem at all. I will go. I'm going to finish this slide first, and then I will go back. All right. So just going to do quickly here. We've got a question involving basically it's involving a couple of things. So it's involving interior angles, and it's also involving a parallelogram, which is something we haven't actually touched on yet, but I want to um, show you. And this is actually a late question from a GCSE. Generally, rules on interior angles and exterior, but we're going to come to, are deemed late in the exam. But we're told here the diagram shows a regular pentagon and a parallelogram, and you need to work out the size of the angle marked X. You must show all your working out. Well, we've already done for a pentagon. We've got it down on the we're told the shape is regular. And if you look back to our table back here, because we've done it already, we can say regular pentagon, individual angles equals 108 degrees. And if you didn't have that here, if you didn't know it off by heart, I wouldn't expect you to, you could use this equation to get that and then divide by the amount of sides. But we've got another side to this question because we've got a parallelogram to deal with. So in a parallelogram, the two opposite angles are the same, and the two side angles equal 180 degrees. So this is always the case if you've got a parallelogram. And a parallelogram, what it means in effect, I haven't drawn things on, is you have two sets of parallel lines in the shape. You have a top and bottom and the two sides. And so this, we don't actually need for this question, but this side here would be 117. And then if we call this here, we'll call it y, and we can say y equals 180 minus 117, which is 63 degrees, and that's just because of the side of the parallelogram. So as I said below, side of parallelogram equals 180. Sorry, it's a bit of a nightmare, this word. Forgetting all my L's. Okay, and so now we know that, we can just say X equals 108, which is each individual side angle, minus 63, which is going to get us to 45 degrees, because we've already worked out the individual side angle is 108, and it's made up of X and Y. So X equals 108 minus Y, so equals 45 degrees. Okay, I'll just give a little bit of time to copy this down, and then I'm just going to go back briefly to the previous slide, and then we will move on. Okay, so just going back to the previous slide, so I'll make it bigger as well. And can you let me know when you are... Oh, we've just lost at the wrong moment. So I'm going to carry on for now, and then if he makes it back later, I'll go back to that slide. All right, we're moving on for now. We are going to look, so that was interior angles. And they said you're also going to get late in the exam, you're going to get exterior angles. And I'm going to give you like a diagram here to sort of show what exterior angles are. So if you carry on a straight line from the sides of a polygon, you make exterior angles. And so again, that's an equation for exterior angles. And so the equation for exterior angles in a regular shape is as follows. And it's got to be in a regular shape for this to work so that they're all the same. But 360 divided by S equals the exterior angle. And where S just means the number of sides. All right, and so for example here above, we've got a triangle, we've got to assume it's an equilateral triangle. An equilateral triangle means all sides are the same. So in an equilateral, it means all sides are equal, hence the word. Triangle, exterior angles equal just 360 over 3, and so equal 120 degrees. So nothing more, exactly nothing more to it than that, but it's an equation you need to be aware of. And again, it often will come up at the end of the exam when you do have an exterior angle question. I'm going to see if I can hunt one down because I didn't actually have one open. If not, I can probably invent one. All right, so yeah, this is the sort of question we're going to pull up, which you will get for exterior angles. And welcome in Ra as well. She's got a question here. And we're told the diagram below shows a regular polygon. The exterior angle is 20 degrees. Find the number of sides of a polygon shown above. So what we can do for this question, we know the shape's regular, so we can use our equation, which is 360 divided by the amount of sides, and we know equals 20 degrees. So basically, there's a rule you can use for rearranging any equation where the side you're trying to find is the denominator, or the number you're trying to find is the denominator, and is this. So if A over B equals C, then A over C equals B. And so this is always the case. And so like just giving it with numbers, for example, e.g. 10 over 5 equals 2. So 10 over 2 equals 5. And so it means if you've ever got a situation like this, if 360 divided by S equals 20, well then we can do a switch here because we know, so 360 divided by 20 equals S. And this is just the same as doing 36 divided by 2. Remember, you can simplify with division, knock off the O's. And so equals 18 sides as our final answer. So hopefully that bit on the side makes sense. I know it's explained a little bit algebraically, so it might not click immediately for everyone, but if you can learn that rule, it can really help on a few areas, things like trigonometry, where you need to rearrange. It can save you some time, and also with these questions here. Okay, so in a sec we will continue moving on. I'll just give a second to copy that. Okay, so what we're going to cover briefly now is angles with parallel lines. So basically, when you have a straight line that cuts through two parallel lines, and parallel lines are lines which always stay the same distance from each other, a number of angles are created, and there are special rules for these which you can follow. So we're going to go through some of these rules here. So our first angle here, we've got shape here. We've got these two angles, and sometimes you'll see this referred to as Z angles. I don't like Z angles because it could be other two angles which don't make a Z, but these are called alternate angles. And so these are the same. So C equals D. So you can see that alternate, well, you might see it referred to as a Z angle, is if you drew in around it, you make a Z. But equally, you could have other angles as alternate. So you could say here, these two angles are alternate to each other, and I'm making some weird upside down Z and so on. So I don't love a name Z angle, but they're called alternate angles, are always going to be the same. They've got the same thing. And you've got another rule, and you're going to find a lot of rules here where things are the same. So this next shape we've got here, sorry, I pressed a weird button now and done something weird. Sorry about that. Give me a second and I will get that angle again. So we've got our next angles here we are going to look at are called corresponding angles. And so corresponding angles are the ones, in effect they correspond, they're in the same part of the shape above and the shape below. And so corresponding angles, these are also the same. And so that means E equals F. In this case, we've got E equals F. And you see they're like in the same part. You've got the shape below and the shape above. They're in the same part of it. But what that effectively means, because you've got the Z angles and the you've got these angles as well, and because you've got the mix of alternate angles and corresponding angles, in fact, all angles drawn on the below shape will be the same. Will be the same. So the two red angles as well as E and F are going to be exactly the same. Right. And then this fits in with the angles in effect we've already drawn on the below shape, but we've got another rule here to prove it. And so we've got here, and this is one of the easier rules to recognize because these two angles, A and B, are basically mirroring each other. They are staring at you, and just like when you look in a mirror, you're going to see a reflection. And so these are called vertically opposite angles. And so these are also the same. So A equals B. A equals B. So you've got here, you're going to have all of these angles staring across at each other, all the corresponding ones, all the alternate angles. Sometimes there are different ways to find the same piece of information, but they are the same as well. And then as a final rule here, and this rule it will become particularly relevant when you do barons. Now, we may not get to barons in this course, except for perhaps in a practice question at the course's final lectures. But for barons, you always need to know this rule to interior angles. And it's the only rule which is in effect different. And so interior angles equal 180 degrees. So G plus H equals 180. But equally, you could have a rule in the other direction because we know G would be basically G would correspond with this angle here. And if you look, the angle above, if we call it like G star plus H, well, they're on a straight line together, so of course they're going to equal 180. And if you put all the angles in, they're going to be on a point that equal 360. So what these rules in effect mean, what these rules mean is that if you have one straight line through parallel lines, if you know one angle, you can work out all the others. Now, in the exam itself, it might be, but they'd throw in an extra additional line somewhere, a couple of extra things, so you'd have to combine this with other rules. It's unlikely unless it was early in the exam, but it would just be as simple as one line through the other areas. And so either way you do it, though these rules should hopefully be possible to combine in that way. Rod, do you know which slide exactly it is? I'm going to, the 14360, I'll come back to that. In fact, I'll give a second on this slide first just to copy it. Is it just the previous slide you want? And yeah, did you get the link through for English? Not sure if you got the link, but of course you can join. Let me know if you didn't get the link through. If you didn't get it through, and I can drop you, I'll forward you the email after class if you haven't got the link. Okay. Sorry, Rob, was it this one you were looking for?
Yeah, thanks.
All right, brilliant. Have you got it now? Or let me know when you're caught up. All right, brilliant. Good to know. Then of course, yeah, of course you're welcome through to English as well.
Okay, yeah, thanks. I'm done.
All right, brilliant. No problem at all. All right, so what we're going to do for the end of this class then, we're just going to do a few more example questions. It might have a couple of additional things we haven't done, but it also will be a combination of some of the rules we have discussed. Now, this next one I do want to look at because, again, just like the question with the parallelogram we did earlier, it's one more quadrilateral which has rules you might have to know, and so people struggle with it sometimes. Even though it's only a question 14 in the exam it was in, I think it's quite a challenging question. So if the diagram shows quadrilateral ABCD with each of its sides extended, and we are told AB equals AD, you need to show that ABCD is a kite, give a reason for each stage of your working. So it might seem a little bit confusing. How do you show it's a kite? And so to solve this question, simply work out each angle one stage at a time using the rules we have learnt. And then if this is a kite, the two side angles will be the same. And so let's draw a little diagram down here. So say if you've got a kite, these two angles here will be the same. Okay, so then with that being said, we just got to use the rules we know. So there's a couple of angles we can work out here because we've got our top angle up here, which is vertically opposite because we've got parallel. We've got these lines are straight and they come from the same point, they meet at the same length. This means these two angles are vertically opposite each other. So we can mark this as 50 degrees. So I'll try and write it a little bit clearer. Degrees. And you can call an angle, by the way, whenever you see angles written with three letters, the middle letter is where the angle is. So this angle would be BCD because it starts at B, goes to C, goes to D. So we can say angle BCD equals 50 degrees vertically opposite angles, or just say vertically opposite. And now we can work out this angle here as well, which would be ADC. And so angle ADC equals 180 minus 75 equals 105 degrees, which is angles on a straight line or straight line, or in one place on a straight line, equal 180. So that's two of our angles sorted. And so now how would we get to angle ABC or CBA? It doesn't really matter which you put first and which you put last, but angle ABC, well, a kite is still a quadrilateral, so rules of a quadrilateral apply, so it equals 360 minus the other angle, so minus 100 plus 105 plus 50. So we add them all together, we get 255, and so equals 105 degrees. And so that's angles in a quadrilateral. So now we've done all of these angles, we can say angle ABC equals angle ADC, and so therefore this is a kite because the side angles are the same. All right, so if you're saying to like prove something is something, that's what you'd have to do on the question. You'd have to follow the rules. You have to follow the rules through, and then if you follow all the normal angle rules, you'd have to know the rules for the shape as well to prove it. We're going to look at another couple of questions here. So we've got ADC is a triangle. So we've got a picture of our triangle here, and we are told AED and ABC are straight lines. EB is parallel to DC. Angle EBC equals 148, angle ADC equals 63, and we need to work out the sides of angle EAB. You must give a reason for each stage of your work. Well, the first thing to think about is which angle is EAB. So EAB is the mid one. So I'm just going to pop an X in here. X is EAB. All right, and so now we know this. Well, just because these lines don't carry on, we've still got parallel lines. We know EB, and we've got the things in it, is parallel to DC, and we've got straight lines going through them. So the rules of parallel lines apply. So you could do this question in a couple of ways. You can maybe do it in one step, or you could do it in a couple of steps. I'm going to do it away with a couple of steps because it's how people normally do it. I mean, yeah, exactly. So we've got angle here, AEB. Now, angle AEB, if you think about it in terms of the angles, AEB corresponds with EDC and say equals 63 degrees because corresponding angles are the same. So if you remember back to our parallel lines before, correspondings are these angles here, which are in the same part above and below. And just because these lines don't continue, it doesn't matter. We can sort of imagine them continue if it helps us visualize. But in effect, this is what we've got. We've got a straight line through two parallel lines. Well, now we've got that. Well, ABC is a straight line. So this angle vertex on our side is simple enough. We can say angle EBA equals 180 minus 148. And so that's going to equal 32 degrees. The reason for that is angles on a straight line. And now we've got that, we can go back to our first rule from today, which is we can either say X or EAB, whatever we call it, equals 180 minus 63 plus 32. Well, 63 plus 32 gives us 95, so equals 85 degrees. This is our final answer, and that's just because it's angles, triangles. You can see this is a classic example. The question looks quite intimidating, but really it's a combination just of the rules we've done today. If you can spot the rules and get on top of it, then theoretically you can answer any question to do with angles. All right, so we've got next question here. And this is a question, you could get a question with angles, which does combine another skill. So often angles questions are applied algebra, as we've seen today. You can also get a question like this one, where here we've got a bit of ratios in it. So we've got a triangle here. We've got told ADB is a straight line. The size of angle DCB to the size of angle ACD equals 2 to 1. And so we need to work out the size of angle BDC. Well, the first thing we can do is we can work out this big angle, the combined of the two, which we can call ACB. So angle ACB is just in a triangle with two, because we've got a big triangle here, equals 180 minus 75 plus 51. So these two together give us 126, and so equals 54 degrees, and that's just because of angles in a triangle. And this is made up of, so angle ACB is made of, well, we've got two angles underneath. We've got angle BCD, sorry, or DCB, we're going to say more today, so we've got DCB, and also we've got a top angle, which is ACD. And so therefore what we want to this, so therefore we need to split 54 degrees, so split 54 degrees in the ratio 2 to 1. And so we can do that. We can just do, remember to split something in a ratio, we just do the 54 divided by the amount of parts. So 2 plus 1, or 54 divided by 3 equals 18 degrees. And so therefore we've got DCB to ACD. It was in a ratio 2 to 1. We now know the scaling factor, which is times by 18. And so it's 36 degrees to 18 degrees. And the angle we want here, we want DCB, which is 36 degrees. And so now we've done that, we can finally work out angle BDC just equals 180 minus 51 plus 36. Because we've got a triangle here, within the triangle we've got two triangles. Well, this is in a triangle, so all of the individual triangles add up to 180. So 51 plus 36 gives us 87, and so equals 93 degrees. And again, it's the same rule as before. It's a triangle. So this is our final answer up here, is 93 degrees. So as you can see with the last question of some of them, it does take a bit getting used to angles questions, because you need to be able to see the different shapes, see the different rules within it, and be confident with the rules. But if you can practice a few of the questions, get on top of the rules we've discussed today, they will give you the basis to do any of these angles questions. All right, but I'm going to leave it there for tonight anyway. So yeah, you are welcome. Thank you so much to all of you. Hope you have a brilliant night. And then we've got lecture again, 7:15 tomorrow. I guess it's on shapes. Yes, it is. It is on shapes tomorrow. So we'll cover a couple of things we've mentioned today and build on from that. So Have a good night, everyone, and I will see you then. All right, bye.